Welcome back, students. In this section, we are discussing about the mirror formula and magnification of spherical mirror. For any spherical mirror, whether it is a concave mirror or a convex mirror, in order to obtain an image, we have to consider an object in front of that mirror. Then, for any spherical mirror, the distance between the mirror and the corresponding object is known as the object distance. That is, the distance between mirror and the corresponding object which we are considering. That is known as the object distance. And the distance from the mirror is always we are measuring from the pole of that mirror. Mirror is a curved surface, and from the center point or that midpoint is known as the pole. From that pole, we are considering the object distance. And usually this object distance is represented with the small letter u. As a result of reflection, the image of the corresponding object should be formed. That depends upon the position of object. Sometimes it may be a real image and sometimes it may be a virtual image. That real and virtual image, that depends upon the position of object and also depends upon the nature of mirror. That we already know. Then the distance between the formed image and the mirror is known as the image distance. Distance between the image and the mirror is known as the image distance. And usually this image distance is represented with the small letter v. If the formed image is a real one, then that image is formed on the left side of the mirror and or in front of the mirror. And if it is a virtual image, then that is formed behind the mirror or on the right side of the mirror. The distance between principal focus and mirror is known as the focal length, and it is represented with a small letter f. Along with these two measurements, that is object distance u and the image distance v, we have to consider two more measurements in case of this spherical mirror. That is, the one is the object height. That is the height of the object which we are considering in front of the mirror. And image height, that is the height or depth of the image formed as a result of the reflection. And usually the object height is represented with small letter h and the image height is represented with the small letter h dash. For every spherical mirror, that is for concave mirror and for convex mirror, these three distances, that is the object distance, image distance and the focal length, are related to each other. The relationship between these three quantities, that is the object distance, image distance and the focal length, that is known as the mirror formula. Relationship between object distance u, image distance v and the focal length small letter f is known as the mirror formula. And that relationship is 1 by f is equal to 1 by u plus 1 by v. That is, reciprocal of the focal length is always equal to the sum of reciprocals of object distance and image distance. Next, we are considering magnification of a spherical mirror. What is meant by the magnification of spherical mirror? Magnification is the ratio of object height and image height. Ratio of object height and image height is known as the magnification. Comparing with the object, what change happens to the image? Sometimes we know that highly diminished images are obtaining, and sometimes same sized images are obtaining, and in other situations highly enlarged images are obtaining. So with respect to the size of object, what change happens to the size of image? That is actually gives the magnification of this spherical mirror. And the magnification is normally represented with a small letter m, and can be mathematically calculated as a ratio between that object height h and image height h dash. Magnification small letter m equal to h dash divided by h. For these spherical mirrors, there exists an alternative equation or an alternative formula to find the magnification. That is the negative ratio between object distance and image distance. That is magnification small letter m equal to minus v by u. This relation we can use in some situations where the object height and image height is not actually known. In that particular situations, we can use this object distance and image distance in order to find the magnification. The magnification of a spherical mirror may be a positive value or a negative value. And if the magnification is obtained as any positive value, then the corresponding image or the formed image will be always an erect image. Erect image means that is a virtual one. And if the magnification is obtained as any negative value, then the corresponding image or the formed image will be a inverted one, that is an real image. Also, the magnitude of magnification, that means only we are considering the value, not considering the sign. If the magnitude of magnification is greater than 1, then that is an enlarged image. If the magnitude of magnification is equal to 1, then that is a same sized image. And if the magnification is less than 1, then that is a diminished image.